Hello, my name is Mark Benson of VMware. I'm going to cover in this short video setting up PC over IP remote access with VMware View 4.6. So what I'll cover in this video, after introducing View remote access, is the View security server. I'll talk about configuring View. This is both the connection server and security server for PC over IP remote access, and I'll use two very specific use cases. The first will be a very simple single security server deployment, and then I'll talk about the use of multiple security servers in a deployment for high availability using load balancing. I'll talk about setting up the firewalls to allow PC over IP in a remote access PC over IP setup, and then I'll go through some basic troubleshooting steps. Okay, so what is View Security Server? Well, I'll start by describing secure View remote access in View 4.5 and earlier. With this version for remote access, it was necessary either to use a VPN connection with PC over IP or to back down to using the RDP protocol encapsulated within an HTTPS secure tunnel. So let's see how this works with security server and RDP. The very first thing is to illustrate where a security server fits within the architecture. So over in the top right hand part of this slide you can see the VMware infrastructure. There's the virtual desktops sitting on vSphere, there's vCenter involved, there's Microsoft Active Directory involved, and at the front here there is View Connection Server. So that's acting as the broker, interfacing to Virtual Center and Microsoft Active Directory to give users, illustrated in the bottom left hand corner here, access to the View environment, manages connections, manages authentication, other aspects of security and entitlements to virtual desktops. So a View security server is basically a subset of the functionality that runs on View Connection Server and is typically deployed within a DMZ. So let's have a look at the connection sequence. A View security server is always connected to a single View connection server. In a high availability deployment there can be multiple connection servers and security servers. So when the user at their View client connects to a View environment, they first make a connection to the connection server, but in this case via a security server. So the user at the View client will enter a URL of the View environment, and that will make an HTTPS connection. They do this, they authenticate through the View client, so they enter their credentials. If those client credentials are correct, then a secure HTTPS tunnel is established between the client device and the security server. So that's illustrated by the red line here that's operating between the View client and the View security server. That is an HTTPS tunnel and is used for encapsulating TCP protocols used to access remote desktops. When a desktop is selected, the remote desktop protocol then goes via this secure tunnel. The advantage of doing this is that it means that over the wire it's HTTPS, and also if the security server is operating within a DMZ, it means that the internet facing firewall does not need to open up RDP, and the RDP protocol is encapsulated within HTTPS over the internet. Okay, let's just summarize the View security server features. And up until now, everything that I've spoken about is the way that it works within View 4.5 and older. I'll come on later on to the updates that have been made in 4.6. So in terms of security server features with 4.5, it is recommended for DMZ deployment or environments with separated networks. And by separated networks, I mean networks where there may be NAT devices, firewalls between networks within an organization. But more generally, it's for DMZ deployments that are implemented for facing the internet. So only authenticated users can gain access through the security server. It's very much tied in with the authentication capabilities of Connection Server. It can ensure that virtual desktop access is only possible for authenticated users. The only desktop protocol that can enter the data center is traffic on behalf of the authenticated user. So it is acting as a gatekeeper in that respect. It ensures users can only access resources, these are the virtual desktops, they are authorized to access, and it's zero administration in the sense that all of the entitlements is managed within View Connection Server, just in the same way that it is for an internal access. When a security server is deployed, there is zero administration of that because basically the security server takes all of its entitlements and authentication information from the connection server. It also offloads HTTPS processing and all desktop protocol traffic away from the View Connection Server. So when doing a large deployment involving a lot of virtual machines and a lot of users, it's a good idea to let the View Connection Server do the authentication, do the management of the virtual desktop pools by interfacing to Virtual Center, and basically offload all of the communication protocols that go on between the View client and the virtual desktops. They're left away from the View Connection Server and only go through the security server. So security server also supports multiple servers which are used for scalability and high availability. Okay, what I'm going to show now is how View access works with PC over IP. And again, this is how it works with View 4.5 and View 4.0 when PC over IP was first introduced. So very similar to the previous diagram, the View client establishes a connection to the connection server. In this case, there is no security server. This is how it would be typically deployed on an internal network, where a View connection server there is supporting internal access only. This is not a remote access scenario. So the user connects to the View connection server and authenticates. Then when the PC over IP desktop is selected by the user, then the PC over IP protocol attempts to go directly to the virtual desktop. What I'm going to show now is how this PC over IP access works with security server. So when going through a security server, again the security server is attached to a View connection server. So there's a pairing process that goes on between the View security server and the View connection server at installation time. So when a user connects to View and selects a PC over IP desktop with View 4.5, whether there is a security server or not, the connection always goes directly to the virtual desktop. This is because View 4.5 security server does not support PC over IP. This direct connection would only be possible on an internal network or if the user had VPN access to the environment. For remote access, shown here where there are firewalls and access across the internet, the only options with 4.5 were to use a VPN or to select the RDP protocol for remote access. With View 4.6, specific PC over IP security server support has been added, and I'll show you how this works. So again, we show a security server paired with a connection server. This pairing is done at installation time. In the same way, the View client can access the View environment, but this time, when they select a PC over IP virtual desktop, what's going to happen with 4.6 is that if the View connection server is configured to gateway PC over IP connections, then instead of the View client connecting directly to the virtual desktop, it will instead be given addressing information to allow it to connect through the View security server. So this time the PC over IP connection will be made between the View client and the View security server, and then assuming that that traffic is on behalf of an authenticated user and that the user is attempting to access a virtual desktop they're authorized to access, then the View security server will forward that PC over IP connection onto the virtual desktop. So this time what we see when there is a DMZ in place and the user is accessing the environment over the internet, that this time the security server is able to act as a secure gateway for PC over IP. So this is new for View 4.6. Of course, direct PC over IP connection is still supported in 4.6. The option to gateway PC over IP is configurable on each connection server. So basically, if this connection server here is configured to gateway PC over IP, then the PC over IP traffic will be gatewayed through the security server. So this is through any security server attached to this view connection server and the view connection server itself. So in an environment where you are supporting both internal PC over IP traffic, so in that case you'd want direct PC over IP, and you are also using the same view environment to support remote access to that environment, then you are likely to want to set up different view connection servers for each case. So you'd have one or two, or however many you needed, connection servers to support the internal network, and then you'd have a different set of connection servers that would be supporting remote access. And in this way, you can decide on each view connection server which ones you want gatewayed and which ones you want direct. Now, in order to allow PC over IP traffic through to the view security server, it is necessary to open up the firewall, both of the firewalls, for PC over IP traffic. Now, on the internet-facing firewall, you'd want to set it up so that it allows the PC over IP protocol to get through just to the view security server. Similarly, on the internal facing firewall, you'd want to configure that so that it allowed the PC over IP traffic to go from view security server to any of the virtual desktops, but you'd want to make sure that that traffic can only come from a view security server. So in terms of the ports that are needed for this, the PC over IP protocol uses both TCP and UDP, both on port 4172, and so the firewall rules basically are to allow TCP inbound from the client to the security server, TCP 4172, and then because PC over IP uses UDP as well, it is necessary to open up UDP port 4172, both inbound and outbound. And essentially the same rule is required on the internal firewall, but that's for traffic between the view security server and the PC over IP supporting virtual desktop. So to summarize those firewall rules, PC over IP between the view client and the security server needs to be opened up, and there is a list of the ports that are needed for this, both TCP and UDP. It's very important that the UDP protocol is allowed in both directions, but the TCP protocol is only needed inbound, so that's from the client to the security server. So there's a similar set of rules for PC over IP between the security server and the virtual desktop. And these rules are in addition to the standard set of rules from 4.5. For a complete list of firewall rules for 4.6, please refer to the View Architecture and Planning Guide for 4.6. Okay, I now want to go through a similar scenario, but this time with a more common view deployment involving multiple security servers used for both high availability and for scalability. This time you can see a load balancer in front of two or more security servers. This load balancer is the same networking device that you may already be using in front of web servers in a similar way. So here the user connects to view connection server, this time via the load balancer, to authenticate. So the user is not going to enter the URL that represents an individual server within the view environment, but a load balanced alias. They will connect via the load balancer and authenticate. So they'll make the connection to the load balanced alias. Then the load balancer will make a decision about which view security server to use. It'll do this based on availability. If they're both available, then the connection will be routed to the view security server that is least loaded. In this way it'll balance user connections across the available security servers. If the authentication is successful, then an HTTPS tunnel is established between the client device and the security server. This HTTPS tunnel connection is made to the individual security server and is not load balanced. The decision about which security server is used has already been made by the load balancer. So this is represented by the red line here. The HTTPS secure tunnel isn't used by all view clients. For example, a Teradici 0 client only needs to use PC over IP connection through the security server, but if the view client supports the HTTPS tunnel, it is necessary to make this HTTPS connection to that security server. Okay, so when a PC over IP desktop is selected and the connection server is configured to gateway PC over IP, then PC over IP goes via the security server. So in order for this to happen, the view client needs to be told the address of the particular security server. With View 4.5 and earlier, the PC over IP destination address was always that of the virtual desktop, but with View 4.6 and when the View connection server is configured to gateway PC over IP, then the view client is given the address of the security server. For PC over IP, that's the PC over IP external URL. So the view client takes that PC over IP external URL, which tells the view client how to connect to the security server. Then the PC over IP connection is made to the security server, and then when the connection is on behalf of an authenticated user and the user is accessing a virtual desktop they're authorized to access, then the View security server will forward that PC over IP connection to the appropriate virtual desktop. So you can see here with firewall rules and the security server being placed within a DMZ and access being over the wide area network, this is an appropriate configuration for supporting remote access for PC over IP. So now let's get into the detail of how this is actually configured. There are three basic setup steps for PC over IP remote access with View 4.6. These three steps can be done in any order, but it won't work until all three have been done. So the first step is to turn on PC over IP gateway functionality on the connection server. When you do this, it means that the connection server and any security servers attached to that connection server will gateway PC over IP. The second step is to set up the two external URLs on each server. This is usually the security server, but if you don't have any security servers in this particular setup, then this is the external URLs on the connection server itself. So there's the external URL, and that's existed with View 4.5 and older, and that's used by the View clients to establish the HTTPS tunnel. That hasn't changed in 4.6, that's just the same. And what is new for 4.6 is the PC over IP external URL, and this is used by View clients to establish the PC over IP connection through the PC over IP gateway when the connection server is configured for gatewaying PC over IP. Then the third step is to set the firewall rules to allow PC over IP. That's both the internet-facing firewall and also the internal firewall, so the ports are shown there. In my View 4.6 setup, I have two connection servers, CS1 and CS2. I have two security servers, SS1 and SS2, each attached to the connection servers. I have a load balancer in front of the two security servers, and I have firewalls protecting the internal network and protecting the DMZ from the internet. This is a setup for remote access, so you can see the View client again over on the left hand side and the cloud representing the internet. This is a very typical deployment. It involves both high availability, multiple servers, it involves load balancing, and it involves a DMZ deployment and firewalls to protect the environment from the internet. So let's say that the IP addresses of each of those security servers are 192.168.1.1 and 192.168.1.2. These are the IP addresses of the security servers themselves, and because of the NAT firewall device here, are not the addresses used by the View client to access the security servers. Instead, the security servers will have external IP addresses that are meaningful on the internet. So you can see here that external IP addresses 10.20.30.1 and 10.20.30.2 are the IP addresses that would be used by a View client to access those particular security servers. Similarly, the load balancer itself would expose a particular IP address and usually a DNS name to the internet to allow the View client to connect. So in this case, this is 10.20.30.9. This is resolvable from a DNS name, in this case of myview.myco.com. And so in an environment set up for remote access, the only thing that the end user needs to know is the name, myview.myco.com. They would use this at the View client to establish a connection to the View environment. In this deployment, I have 3 virtual IPs set up here, or VIPs. This is known as the N+1 VIP model, where we have a VIP for each of the security servers in the environment, plus 1 for the load balanced VIP. So if, for example, you have a deployment of 5 security servers, you'd expose 6 VIPs, 1 for each of the security servers, plus 1 for the load balancer. I should point out here that there are some techniques available to be able to just expose a single VIP for an entire View environment. The problem is these are not always reliable for all situations. They rely on functionality within the load balancer to ensure session affinity or stickiness, but these usually depend on reliable source IP addressing information, and in environments where the source IP address is not accurately passed through from the network, this can result in uneven load across security servers, or can even result in misrouted packets. You should consider the single VIP option very carefully for your environment, and if you want to go ahead with it, get detailed information from your load balancer vendor before proceeding with this model. For this setup, I'm going to stick with the N+1 VIP model shown here. Okay, so let's configure this environment. In this case, it's a new View 4.6 install, but it would be the same if it was an environment upgraded from an earlier version, such as 4.5. I'm going to use View Administrator, and I've connected to the environment from a web browser. So what we see here under View Configuration, under Servers, is my 2 connection servers, CS1 and CS2, and my 2 security servers, SS1 and SS2. Now the important things to check here is the version of each of these, and here you can see that my 2 connection servers are running View 4.6, and the same with my security servers, again running View 4.6. It's important to check these because the feature of being able to gateway PC over IP just came in with View 4.6. So if you have an earlier version, it's important to upgrade. So step 1 in my configuration is to configure each connection server to gateway PC over IP. So to do that, I select each connection server, I select Edit, and here you can see that by default HTTPS Secure Tunnel is enabled, so automatically we'll be using Secure Tunnel connection to the desktop. But what's new in 4.6 is PC over IP Secure Gateway. Use PC over IP Secure Gateway for PC over IP connections to the desktop. So what I need to do here is select that. I'm doing this for the particular connection server. So I've selected that now for CS1, and I need to do the same for CS2. So that's the first configuration step done. Then the second thing I need to do is configure the external URLs for each security server. So again, I'll select the individual server, I will click Edit, and what we see here is the default settings for each. So the default setting for the external URL is the computer name itself, in this case SS1, and for PC over IP external URL, which always uses an IP address, it's using the IP address of the actual security server. So I need to change these. I need to change these to the external VIP for each security server. So for this one, I'm going to change SS1 to be 10.20.30.1. That's my external VIP. And I'm going to do the same here, 10.20.30.1. Now in the case of an external URL, I could use a name associated with this IP address, but in the case of the PC over IP external URL, I must use an IP address. So what I've done here for consistency is just use the same external IP address for both. So you can see now 10.20.30.1 used in both cases. I'll click OK on that. I'll do the same now for SS2. Edit that. Change the default settings. I don't want SS2. I want 10.20.30.2. And the same for PC over IP external URL here, 10.20.30.2, and click OK. That's it. That's both configuration steps done through View Administrator on a pure View 4.6 default install to select PC over IP gateway for each connection server and to set up each external URL for the security servers. Another thing to note here is this column here, PC over IP, which shows a tick against SS1 and SS2. That basically means that PC over IP is supported on that server. So in addition to checking the version to make sure that it is 4.6 on each security server, it's important to make sure that PC over IP gateway functionality is also supported. The reason why it may not be supported is if the security server has been installed on Windows Server 2003. The new PC over IP gateway is only supported on Windows Server 2008 R2, and that's the 64-bit operating system. This feature takes full advantage of the 64-bit operating system, and also if the Intel AES-NI instruction set is supported, the PC over IP gateway functionality will take advantage of that. In the case of the connection servers, they need to be View 4.6, but they don't have to be on Server 2008 R2 if you're not using the PC over IP gateway functionality on those servers. So you could have a situation where you've got the connection servers on Server 2003, still 4.6, but the security servers that are connected to them are running on Server 2008 R2. Okay, so let's just recap what we've done here. Using View Administrator, I've gone in and changed the configuration for CS1 and CS2, and in both cases I've said that I want PC over IP to be gatewayed. Then what I've done is gone into each security server and changed the default settings for the external URL and PC over IP external URL. Leaving them at the default values would not be good for this situation. It would have mentioned SS1 for the external URL, and it would have mentioned the local IP address here for the PC over IP external URL, and neither of those would have been good for the remote View client needing to use those values to access the View environment. They need to use the external URLs for each of these, and so that's basically the external VIPs that are here, 10.20.30.1 and 10.20.30.2. So I went into each security server configuration, SS1 and SS2, changed the external URL to reference that external IP address, and the same for the PC over IP external URL, which also used those same addresses. If in your environment you just have a single security server and no load balancer, then the environment can be exposed as a single VIP, for example 10.20.30.9 as shown here, in which case both of the external URLs, the main external URL and the PC over IP external URL, can both be set to 10.20.30.9. So the third and final configuration step for remote access is to go into each of these firewalls and make sure that the PC over IP protocol is allowed through. This is to make sure that the View client can access each security server using PC over IP, and also that each security server can access the virtual desktops through PC over IP. In addition to allowing PC over IP through the firewalls, it is also necessary to open up the other ports required by View 4.5, such as HTTPS on the internet-facing firewall. For a complete list of the firewall ports required at both the inner and internet-facing firewall, please refer to the View 4.6 Architecture and Planning Guide. So in the situation where you're supporting remote access for View, but also you're supporting local access to the same View environment, you may have separate connection servers to support the local access case. So let's extend this diagram now to show two more connection servers, CS3 and CS4. And they're basically in this picture to support local access. So this is a local access user not using View security servers, just accessing the environment locally. So for those users, when they connect to CS3 or CS4, they're going to be able to perform PC over IP directly to the virtual desktops. They don't need to go through a security server. They're not accessing the environment remotely. So in this case, CS1 and CS2 have been configured to gateway PC over IP, but CS3 and CS4 have not, and that means that they will perform PC over IP connections to users of CS3 and CS4 directly. It is a good idea generally to separate connection servers to support remote access and local access. In addition to needing different configuration settings for whether or not to gateway PC over IP, there may be other requirements there as well. An example of this is if you wanted RSA Secure ID authentication to apply for remote access users, but for local access users, Active Directory username and password is sufficient, in which case you'd configure CS1 and CS2 to do Secure ID authentication. You'd leave CS3 and CS4 to the default of Active Directory password authentication. The other reason you may want to do this is if you wanted to restrict entitlements to virtual desktops based on whether the user was accessing the environment locally or remotely. There are several use cases where local access to virtual desktops are permitted from a security perspective, but are denied from a remote access perspective, and the use of View entitlements tags for restricted entitlements will apply on a connection server basis. So CS3 and CS4 may permit access to particular virtual desktops, whereas CS1 and CS2 would not, which means that the same user accessing the environment locally would be able to access those virtual desktops, but the same user accessing the View environment remotely would be denied access to those. So these are several reasons why you would want to separate out connection servers, some to support local access and some to support remote access. The final point worth noting in this diagram is although this diagram just shows a single security server per connection server, View does support the ability to have multiple security servers attached to each connection server. The reason why you may want multiple security servers per connection server is to manage the PC over IP load through the PC over IP gateway component on the security server. Security server itself supports up to 2,000 sessions active at any one time, but it may well be, because of the load characteristics in your environment, that you will want to split that load out into multiple security servers. For example, having 2 security servers with 1,000 sessions each, or maybe 4 security servers, each with 500 sessions each. So you saw here that I set up the external URLs for each security server using View Administrator. There is an alternative method of doing this, and that is at the time that the security server itself is installed and paired with the connection server. So when you install View Security Server with View 4.6, at installation time, you'll be given the opportunity to specify the external URLs. So that's the HTTPS tunnel external URL and the PC over IP external URL. So here you can see when SS1 was installed, I get the option here to be able to specify those external URLs at installation time. I didn't do that in my setup. Instead, I left it at the defaults and then went in afterwards and set these values up using View Administrator. But what I could have done instead, just for the external URLs, is specified the values at installation time. So what I could have done is specified the external URL there, https 10.20.30.1:443, and similarly the PC over IP external URL, and then at installation time, when the security server is securely paired with the connection server, then the external URL settings are done immediately. This is just an alternative method of setting the external URLs. It's the same effect, whether they're set up at installation time or set up later through View Administrator. Okay, so the final topic I want to cover here is troubleshooting PC over IP remote access with VMware View 4.6. So I'll go through some of the common issues. There are three main issues. The first is to make sure that the connection server is configured to gateway PC over IP. So each connection server involved in PC over IP remote access must be upgraded to View 4.6. It is not supported in older versions. In addition to that, it is important to select Use PC over IP Secure Gateway for PC over IP connections to the desktop in the connection server configuration. When you first install View 4.6 or when you upgrade from an earlier version, this is not set by default, so you need to specifically go into the connection server and tick the box. The second common issue is make sure the external URLs are set correctly. Make sure you know the difference between the internal IP addresses of each security server and the IP addresses that are exposed to the internet or the external network that are usable by the View client. It's also important that the external URLs are not load balanced. As you've seen in the previous diagrams and the previous setup steps, it's very important that each external URL directly connects the View client to the individual security server. So they must represent access to the specific server and not be load balanced. If they are load balanced and the connection were to go to the wrong security server, the PC over IP connection through the gateway will not work. The third area is to make sure that PC over IP protocol is not blocked by any firewall or web proxy. If the PC over IP protocol is blocked, then PC over IP will not work. That's true of every protocol. So have a look at the View client logs and also the firewall logs. Test from different locations. If it works from some locations and not others, it could be that on the client side there is a web proxy or a firewall that is blocking PC over IP. Gatewaying PC over IP over the internet in this way does work in the vast majority of cases and will absolutely give the best user experience over the WAN. For the small number of cases where PC over IP is blocked and really can't be opened up, then assuming you're not using a VPN to access the View environment, then it will be necessary to back down to RDP. So to summarise PC over IP remote access with View 4.6, firstly, use View 4.6 on all connection servers and security servers. Plan your deployment, considering the needs for local access and remote access. Where you can do direct PC over IP, such as on an internal network, do so. Use PC over IP through security servers for remote access only. Understand the difference between the external IP addresses used to access the environment and also the internal IP addresses. And finally, perform the three configuration steps that I've been through. Turn on PC over IP gateway functionality on the connection server, set up the two external URLs on each server, and set the firewall rules to allow PC over IP. For more information on this subject, please refer to the View Administration Guide for 4.6 and also the View Architecture and Planning Guide for 4.6.